Thanks for stopping by. Today we're going to talk about genetic drift. So genetic drift is a mechanism of evolution that's responsible for random changes in a gene pool. All right, it happens to all populations, but it has a much more visible and drastic effect in small populations. Right? It's driven by chance and not selection, so evolutionary fitness doesn't matter here. It's all random. Natural selection doesn't come into play when we're looking at genetic drift. Right? And there's two main types of genetic drift. You have the founder effect and the bottleneck effect. And we'll look at some examples of both of these. So let's say that you have a town, call it Darwinville, and you have 100 people that live in this town. And of those 100 people, 95 of them are right-handed, and the other 5 are left-handed. And let's say a small group of about 4 people from this Darwinville decide to move away and settle some new uninhabited land. And let's say these 4 individuals happen to all be left-handed. Right, their gene pool is now drastically different from the group they left because all their descendants will be left-handed. Right, this is an example of the founder effect, when a small group leaves from a population and carries with it a new gene frequency. Okay, so let's go back to our town of Darwinville, where we now have 96 people and only 1 lefty. Right, let's say a freak storm comes through and kills 75 of the residents of Darwinville, including our last left-handed person and all remaining recessive left-handed alleles. Right, and then the new population, now 21 individuals, will have no left-handed posterity from this point on. So this is an example of the bottleneck effect, when there's a random reduction of the population due to some random event.